This is a short presentation on the ROLAND SND40 weld seam detection system. At the current time, cabled up is a sensor called an NS9EC, is the short abbreviated name. It does have some nomenclature after that. It is one of many different sensors available. Most all the sensors have a spring-loaded element in the center, so that way it auto-adjusts to the size tube itself. This sensor can start out at a 10 millimeter diameter tube. The ROLAND solution is comprised of the SND40 controller itself. There are actually two cables that interconnect an EC sensor and then the sensor itself. This is an NS9, as I said, EC. Weighs in roughly at about 14 pounds. And anything else beyond this is taken care of by a machine builder or by the customer themselves, which would be the drive system to actually place and lock the tube into a rotation system to be able to rotate the tube without any slippage, and then also to be able to lower the sensor down onto the tube and raise it back up off the tube. That is not handled by ROLAND. At this time I will place the sensor into our test drive system, which is only used for application testing. At this point in time I can manually raise the sensor up off the tube and lower it back on again. And if I look at the screen itself, this is a detection from a previous run of this tube, and it's showing me I had good results. This is in a manual mode. It shows all this information. Normally it just shows the DV itself. Up in the top area we have yellow and green signal. The green signal is the raw signal from the tube, which is shown there by itself. At this time I can turn on the filtered just by itself and putting both on top of each other. When we're rotating the tube, we're detecting more than just the weld seam. We're seeing any anomalies in the tube from the forming process. With the eddy current settings that we have set up in here, we're able to filter out the majority of all the noise from the rest of the perimeter of the tube. At this time I'm going to actually hit the start button, which is going to be here. This would normally be done all by the PLC itself, and I'm going to pan over to the tube itself and show where the tube weld seam is not underneath the sensor itself. There's the weld seam itself right now. I'm going to just rotate it around a little ways and hit the start. And we'll take roughly 4 revolutions, and you can see the dark line from the weld seam. With our offset, we're able to place the weld seam directly up underneath the sensing element itself on the sensor. You can see the rollers of the sensor on how it cradles the tube. And we'll hit start once again. And you can see it's actually placed it there at that point. So it takes 4 revolutions. It's gathering the data. Right now it is turning that tube at roughly 106.9 RPM. And once again, if we come back over here, now at this point in time I have a satisfactory detection. All depends on where we look at it across the length of the tube itself. If I place it in another spot of the tube here, moving the tube left and right, I'll hit it once again. We're going back to a good detection of 19.2. Basically this is telling me that over the length of the tube, the characteristics of the tube are not exactly identical as it goes down across the tube. On this particular tubing, I've been seeing anywhere from satisfactory to actually very good. So it's averaging in this good area, which is a pretty good detection at that point. So once again, the filtered, the raw signal, and both on top of each other. The SND40 EC MF IO weld seam detection controller.